Okay, then 1 plus 5i divided by 1 minus 3i, its answer is negative 7 over 5 plus 4 over 5i, which is in algebraic form. This is its answer. So let us try to see number 3. Number 3 is saying, find 1 over z if z is equal to 4 plus 2i. So we're going to find 1 over z if z equal to 4 plus 2i. Actually, this is division. But remember, we're not allowed to write a complex number in this form. We are supposed to write a complex number in algebraic form. So who can try this number? Anyone, please? Yeah, sure. So this one is 1 over z. The answer is 1 over 4 plus 2i. We are going to express this in algebraic form. You know that from z1 over z2, which is equal to z1 times z2 conjugate, divided by z2 times z2 conjugate. We just take numerator times the conjugate of denominator divided by denominator times its conjugate. So our denominator here is 4 plus 2i. So now 1 over 4 plus 2i, the answer is 1 into bracket. The conjugate of 4 plus 2i is 4 minus 2i. Then divide by 4 plus 2i into bracket 4 minus 2i. So now the answer is 1 times, you know that 1 times n number is that number, which is 4 minus 2i, divided by 4 times 4, that is 16. 4 times negative 2i, that is negative 8i. 2i times 4, that is 8i. Then 2i times negative 2i, that is negative 4i squared. So meaning that 1 over 4 plus 2i, the answer is 4 minus 2i divided by 16. Then negative 8i plus 8i, that is 0. I squared times negative 4, that is positive 4. So 1 over 4 plus 2i, the answer is 4 minus 2i divided by 20. So which is 4 divided by 20 by 4, 1, by 4, 5. That is 1 over 5. 2 divided by 20 by 2, 1, by 2, 10, minus 1 over 10i. So this is 1 over z. And it is the final answer. Because as you can see, it is written in the form of a plus what? It is written in the form of a plus bi. Because our n now, it is 1 over 5. Our b now, it is negative 1 over 10. This form is algebraic form. So this is the final answer because it is written in algebraic form. So let's go to number 4. Number 4, it is saying find the real values, find the real numbers, find the real numbers, x and y, such that we have x plus yi into bracket 3 minus 2i. which is equal to 6 minus 17i. So we're going to try that one. Please, anyone who can try this number. It is saying that find the real numbers x and y such that x plus yi times 3 minus 2i equal to 6 minus 17i. So who can try this? Yeah, remember, when you have like 2x equal to 5, how can you solve this? The unknown value is x. Because the unknown value is x and it is a product equal to another number. So the problem is this x, and I need the value of x. So to do this, if you remember, we just divide by 2. Both sides, in order to stay with x only. So when you divide by 2 both sides, our x is 5 over 2. So which is the answer? So now, it is the same way. We have x plus yi into bracket 3 minus 2i equal to 6 minus 17i. So how am I going to do that? I need the value of x and the value of y. But I have this complex number here. So it is a product equal to another complex number. So I want to remain with this. So I have to divide both sides this one, as the way I've done it here. So which means that x plus yi into bracket 3 minus 2i, we divide both sides, 3 minus 2i, equal to 6 minus 17i, divided by 3 minus 2i. Are we together here? Yes. So now, this cancel with that one. We remain with x plus yi equal to 6 minus 17i, divided by 3 minus 2i. So now here, what are we going to do here? We're going to apply division, because this is division. So we're going to express this one into algebraic form. So the answer is 6 minus 17i over 3 minus 2i times the conjugate of denominator. So our denominator is 3 minus 2i. Its conjugate is, yes, it is 3 plus 2i. 3 plus 2i. So which is 6 times 3, that is 18. 6 times 2, that is 12. 12i. Negative 17 times 3, what is the answer? That is negative 51i. Then, negative 17 times 2, there is negative 17i times 2i. Negative 17 times 2, then I times I. So what is 17 times 2? It is, what is the answer? When you take 17 times 2, that is 34. That's negative 34i squared. Divided by 3 times 3, that is 9. 3 times 2i, that is 6i. Negative 2i times 3, that is negative 6i. Negative 2i times 2i, that is negative 4i squared. So now here, then x plus yi equal to 18 plus 12i minus 51i minus 34i squared divided by 9 plus 6i minus 6i minus 4i squared. Our x plus yi, the answer is 18 12i minus 51i. So what is 12 minus 51? It will be 39, negative 39i. Then I squared, it is negative. Negative times negative comes positive. Positive, that is positive 34. Divided by 9. 6i minus 6i, it is 0. I squared is negative 1. Negative 1 times negative, that's positive 4. So here we have 18 plus 34. So what is the answer? 18 plus 34. So it is 52. Minus 39i divided by, what is 9 plus 4? The 13. So which is x plus yi. Then there, x plus yi equal to 52 divided by 13. What is the answer? The answer is 4. Then what is 39 divided by 13? The answer is 3 minus 3i. So this is equality. We're going to use equality of complex numbers. If we remember, we saw that when two complex numbers are equal, the real part must be equal to the real part. The real part of the left-hand side must be equal to the real part of the right-hand side. And imaginary part of the left-hand side must be equal to the imaginary part of the right-hand side. So our x here is equal to 4. So x equal to 4 and y equal to negative 3. So now our set, it is a coordinate of x, y, which is 4 and negative 3. So that's the answer. Is there any question about here? So thank you. There is no question. So let us go to see how we can apply division to solve other questions. We have a remark. So remark number 1, when you have 3 distinct points like A, B, and C with affixes ZA, ZB, and ZC, respectively. Those points or those complex numbers are collinear if and only if ZC minus ZA divided by ZB minus ZA are a member of real number. So what does it mean? When you have 3 points, and those points, they form their complex numbers. Those complex numbers are collinear. When you take the third point or the third complex number minus the first one divided by the second complex number minus the first one, and you get a real number. That's when those 3 complex numbers are collinear. Number 2, when those 3 distinct points A, B, and C with affixes ZA, ZB, and ZC, and ZC, respectively, are perpendicular, they are perpendicular if and only if ZC minus ZA divided by ZB minus ZA are pure imaginary.